a map from sample space to set of real numbers. S is sample space. Now two types of random variable. So random variable two types, and discrete and continuous. So discrete random variable and continuous random variable. Although mixed type of random variable means some portion discrete, some portion continuous, but mainly these two classification: discrete random variable and continuous random variable. So what is discrete random variable? Range of x. So suppose random variable is x. So range of x finite set or countable infinite. Range of x is finite or countably infinite. That is for discrete random variable. Continuous random variable range will be either an interval or disjoint union of interval. Continuous range of x is either an interval or disjoint union of interval. Disjoint union of interval. I am writing next. Okay, so a random variable x is said to be continuous. A random variable Rvx is said to be continuous random variable. Continuous random variable if two condition: range of x is an interval. Interval means is an interval on the real line, means line segment on the real line. So suppose this is the all values within this. So it is an interval or union of disjoint interval. So this one plus this one, this one. So this portion, that way. Range of x is an interval or union of disjoint interval. Not only that, along with another condition, probability at a particular point will be 0. If you remember discrete case, at a particular point we may get 0 or non-zero, but continuous case at a particular point value will be 0. That is the thing. So definition is okay for continuous random variable.
Yes, sir.
One example, suppose depth of a pond. Let x equal to depth of a pond or lake. Suppose minimum depth is say 1 meter and maximum is 10 meter. Suppose let minimum depth 1 meter, maximum depth 10 meter. Then x belongs to which range? 1 to 10.
Yes.
X takes all values, so that is an interval. So x is continuous random variable. Continuous random variable. Is that okay? So what is discrete random variable? What is continuous random variable?
Yes, sir.
Okay. So what continuous thing we will study later. Now we are going to the discrete thing. Sorry. So two types of random variable, discrete, continuous. Discrete if the range of x is finite set or countable infinite set. After that we have defined probability mass function. So what is probability mass function? That is for discrete random variable. Small px is probability mass function. Probability of the event capital X equal to x means when for all event for which value of the random variable is x, that is probability mass function. Then we have calculated for some events, it has two properties, it will be always greater than equal to 0 and summation px for all possible x it will be 1. So up to that we have studied. So before going to the next thing, we will solve some question related to random variable. So see here, question 1, section 3.1. A concrete beam may fail either by shear or flexure. Shear S, flexure F. So two type of failure is there. Two type of failure, either by shear, either by S or by F. Suppose that three failed beams are randomly selected, and the type of failure is determined for each one. So three failed beams are selected, and type of failure is determined. So by failure by S or F, by shear or friction. Now X is number of beam among the three selected failed beams by shear. So number of beams among the three selected beams failed by shear. So number of S. List each outcome in the sample space along with associated X value. So S or F, three failed beam. So for first one either S or F means two choice. Second one either S or F, two choice. Third one either S or F. That means 2 into 2 into 2, 2 cube. So 8 choice. So 8 outcomes will be there. So what are the outcomes? So S beam is failed due to shear, F beam is failed due to flexure. So either all are S or SSF, SFS, SFF, FSS, FSF, FFS, FFF. These are the 8 outcomes. Now X is number of beams among the three selected beams that are failed by shear. Basically X is number of S. SSS 3S 3, SSF 2S 2, SFS 2S 2. Here 1S 1, 2S 2, 1S 1, here 1S 1. Here no S, that's why it is 0. Is this example okay? Just like coin, tossing a coin 3 times, same thing. Another one, see 6. Starting at a fixed time, each car entering an intersection is observed to see whether it turns left or right or goes straight ahead. So starting at a fixed time means at a particular time we are starting, each car entering an intersection is observed. So whether it turns left or turns right or goes straight ahead. Turn left L, turn right R, goes straight ahead A. The experiment terminates as soon as a car is observed turn left. So we stop the observation when a car turns left. So if it goes straight ahead or right, then we will observe the next car. That also same, then we will observe next car. That way we will continue, and once a car turns left, we will stop the experiment. So now now what are the outcomes? So suppose first car turns left, we will stop the experiment. That case it will be L. Outcome will be L. Suppose second car turns left, then first car either turns right or goes straight ahead. So either RL or AL. Suppose After 3 cars observed, we will stop the experiment. That means third car turns left. Before that, all the 2 cars do not turn left. That means either right or straight ahead. That case, it will be RRL, RAL, ARL, AAL. That way we can enlist the outcomes. So if you observe, for all outcomes, the last one will be L. Before that, they are either R or L. That is the thing. So any outcomes, last one will be L. Before that, all are either R or L. Means combination of R and L. Now, that way, how many outcomes will be there? Infinite number of outcomes will be there. Because we do not know which car turns left. Maybe up to 500 cars all do not turn left. So that's why we do not know whether a car turns left or not. Okay, so outcomes are, see here, it is written left L, right R, straight ahead A. So outcomes will be LR, RL, AL, RRL, RAL, ARR, ARL, AL, that way. So last one will be L, before that all are either R or L. Either R or S, not L, that way. So sample space is okay for this question? Hello?
Yes, sir.
Now,
Yes, sir.
X counts the number of car observed. X is number for XL. X of L is 1. X of RL 2. 2 car observed 2. X of AL 2. X of RRL 3. RAL 3. ARL 4. AL 3. Next one it will be 4. That way 1, 2, 3, 4 and so on. Means any positive number is any positive number is a value associated with X. Now list 5 outcomes and their associated X value. So X of L 1, X of L 2, that way it is written. Is this question okay?
Yes, sir.
Now next question is little bit different. Next is question 10. The number of pumps in use at both a 6 pump station and a 4 pump station will be determined. Number of pumps in use at a 6 pump station and a 4 pump station. 6 pump stations means there are 6 pumps, number of pumps in the station is 6. So at a time, either no pump working or 1 pump working or 2 or 3 or 4 or 5 or 6. So basically 6 pump station means there are 6 number of pumps and either no pump working or 1 or 2, that way up to 6. Similarly 4 pump station, there are number of pumps in the station is 4. So either no pump working or 1 or 2 or 3 or 4, that way. So now give the possible values of each of the following random variable. So T is total number of pumps in use. So before that 6 pump station, suppose number of pump in use 6 pump station is 8. Here writing question number 10. Suppose A equal to number of pumps used in 6 pump station. 6 pump station. So what are the possible value of A? Either no pump working or 1 or 2 or 3, that way up to 6. A values are, one thing I will check whether A is there or not. Okay, A possible values of A are 0, 1, 2, 3, 4, 5, 6. Is that okay? Number of pumps working in 6 pump station. That possible choices are 0 to 6. Is that okay? Hello?
Yes, sir. Yes, sir. Yes, sir.
Then B is number of pumps used in 4 pump station. So what are the B value? 0 to 4. 0, 1, 2, 3, 4. Then first part. Total number of pumps in use. Part A is T equal to total number of pumps in use. So what will be that? That will be A plus B such that A belongs to A, B belongs to B. Suppose from station A station 6 pump station, A number of pump are in use. Station B, station next station B number of pumps in use. So it will be A plus B. Correct or not? So what will be the minimum value of A plus B? 0. So it may happen both the station no pump working. In that case, what is the value? So A plus B, A takes value 0 to 6, B takes value 0 to 4. So A plus B, what is the minimum value of A plus B? 0. And maximum value 6 plus 4, 10. So T value will be 0 to 10. T will be 0, 1, 2, that way 3, 4, 5, 6, 7, 8, 9, 10. Because minimum number of pumps in use, so both the stations no pumps is in use. No pumps are in use. So 0 plus 0, 0. Or all the pumps are working in both the stations. That case it will be 10. So any number in between that also work. That's why T varies over 0 to 10. Is that okay? Hello?
Yes, sir. Yes, sir.
Then next part. Next is X equal to the difference between the numbers in use at station 1 and station 2. The difference between the numbers in use station 1 and station 2. X, the difference between the numbers used in station 1 and 2. Station 1 means 6 pump station. Station B means 4 pump station. So that means suppose stations 1 A pumps are working and stations B pumps are working. So A minus B such that A belongs to A, B belongs to B. So A minus B. Now if we subtract this, see 0 minus 0, 0, 0 minus 1, minus 1, 0 minus 2, minus 2, 0 minus 3, minus 3, 0 minus 4, minus 4. So 0 minus 1, minus 2, minus 3, 4. If we subtract from 1, 1 minus 0, 1, 1 minus 1, 0, 1 minus 2, minus 1. That way if we do, what is the minimum value? Minimum value is minus 4. What is the maximum value? 6 minus 0 is 6. So whenever we will do A minus B, what is the minimum value of A minus B? That will be 0 minus 4. So minimum value of A minus B is minus 4. And maximum value of A minus B, 6 minus 0. That will be the maximum value. That's why it will be minus 4 to 6. So X varies over minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, that way up to 6. That is difference between the number of pumps in use station 1 and 2. Is that okay? Hello?
Yes, sir.
Then
Yes, sir.
C is maximum number of pumps in use at either station. C is U maximum number of pump in use either station. So suppose A number of pump is used station A, B number of pump is used station B. So what will be that? That will be maximum of A comma B. So which set maximum of, sorry, that will be the set maximum of A comma B such that A belongs to A, B belongs to B, means all such order pair. So maximum of A comma B. Now see here. So what will if that 0 maximum will be 0, 0 or maximum will be 1, 0 maximum will be 2, 0 maximum will be 3, 0 maximum 4, 1 maximum 1, 1 maximum 1, 2 maximum 2, 3 maximum 2. That way if we calculate, what will be the minimum value? 0. What will be the maximum value? 6. That so it varies from 0 to 6. This varies from, if we take these pairs, then for a pair AB, max 0, 1, 2, 3, 4, 5, 6. Is this okay?
Yes, sir.
See, either no pump working, or both the station at most one pump working, or in both the station at most two pump working. That way. 0, 1, 2, 3, 4, 5, 6. That way you can think. Both the station no pump working, 0. At most one pump working, 1, 2. That way it is possible up to 6. So 0 to 6. Next one. The number of station. Earlier question was number of pumps. Z is number of station having exactly 2 pumps in use. Sorry. Z is number of station exactly 2 pumps in use. See, how many stations are there? 2 stations. So Z value will be either 0, 1 or 2. Now we have to see both the stations exactly 2 pumps are not working. That case value will be 0. Exactly one station, exactly 2 pumps working. 1, then 2. This is our Z value. So either both the station exactly, so station 1 2 pump working, station 2 2 pumps working. That case value is 2. Station 1 2 pump working, but station 2 exactly not 2 pump working. So that case it is 1. Same way we will get 1, and both the station exactly 2 pumps are not working. That case it is 0. So Z takes value 0, 1, 2. Is that okay? Hello?
Yes, sir.
Okay.
Yes, sir.
Okay, then we will go to next chapter, some question.
Yes, sir. Yes, sir.
Because
Yes, sir.
depending on the topic, short questions may come. Whatever
Yes, sir.
that thing. 13 I have written there. See. A mail order computer, question number 13. A mail order computer business has 6 telephone lines, and let X denote the number of lines in use at a specific time. So Mail order computer business has 6 telephone lines, and X denote the number of lines are in use at a specific time. So what are the X value? 0, either no lines are in use, or 1 or 2 or 3, that way up to 6. So X takes the value 0, 1, 2, 3 up to 0, 1, 3, 0, 1, 2, 3, 4, 5, 6. Now corresponding probabilities are given. Px, probability mass function. What is the meaning of that? Suppose 3. At 3, Px is 0.25. That means at a specific time, 3 lines are in use, that probability is 0.25. Suppose this one, 0.06. At a specific time, 5 lines are in use, that probability is 0.06. That way it is given. Remember, total sum will be 1. 0.10, 0.25, if you check, that will be 1, because otherwise it will not be probability mass function. Now we will calculate probability each of the following events. So first one, at most 3 lines are in use, 13A. is probability of at most 3 lines are in use. So X equal to number of lines are in use. That means it will be probability of X less than at most 3. So below 3 also possible. That's why probability of X less than equal to 3. Is that okay?
Yes, sir. Yes, sir.
Now X has how many values? 0, 1, 2,
Yes,
3,
sir.
4, 5, 6. So less than equal to 3. What are the values? Probability of X equal to 0, probability of X equal to 1, probability of X equal to 2, plus probability of X equal to 3. These are nothing but probability mass function. So P0, small p0, small p1, small p2, small p3, p0, p1, p2, p3. So 0.10, 10, 15, 20, 25. 10, 15, 20, 25. So this is 30 plus 40, 70, 0.70. So at most 3 lines are in use, that is 0.70. That's probability. Suppose next part. Fewer than 3 lines are in use. Fewer than 3 lines are in use. That means what? Probability of X less than 3
Yes, sir.
means P of X equal to 0, P of X equal to 1, P of X equal to 2. So P0, P1, P2. So values are given there. 0.10, 0.15, 0.20. 0.10, 0.15,
Yes.
0.20. You add all the things. Now I am showing the answer of the remaining parts.
Yes, sir.
See, at most 3 lines, X less than equal to 3, P0, P1, P2, P3. Fewer than 3 lines, X less than 3, so 0, 1, 2, P0, P1, P2. Then at least 3 lines are in use. At least 3 means X greater than equal to 3. X greater than equal to 3. So what are the value? 3, 4, 5, 6. P3, P4, P5, P6. Values are put, that way calculated 0.55. And here it is same thing is done. by complementation rule. Probability of x greater than equal to 3, complement even is x less than 3. So 1 minus probability of x less than 3. Already it is calculated x less than 3, 0.45. So 1 minus 0.45, that is 0.5, 0.55. Both way you can do. Then D, between 2 and 5 lines are used. In 2 and 5 lines, inclusive are in use. Means endpoints are in use. Between 2 and 5. So 2 less than equal to x less than equal to 5. 2 and 5 lines inclusive are in use. That's why 2 less than equal to x less than equal to 5. So 2, 3, 4, 5. P2, P3, P4, P5. Between 2 and 4 lines, inclusive are not in use. So 2 to 4, but endpoints are not included. So 2 less than x less than 4. So only x equal to 3, so P3. Then at least 4 lines are not in use. So 4 lines are not in use. At least 4 lines are not in use. Means either 4 lines are not in use. That means or either 4 lines are not in use or 5 or 6. So total 6 lines. At least 4 lines are not in use. Same as at most 2 lines are in use. Same event. So at most 2 x less than equal to 2. So P0, P1, P2. That way it is calculated. Is this okay? This question?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Okay, then we'll define another term, cumulative distribution function. So next class we will study their properties. So suppose x is a discrete random variable and small px is the corresponding probability mass function. Then cumulative distribution function, that thing is given cumulative distribution function or we will write CDF. So that thing is denoted by capital Fx. What is capital Fx? Probability of x less than equal to x. I am writing next here. Capital Fx is called cumulative distribution function. What is that? Probability of all such event for which value of the random variable is at most x. Okay, for which value of the random variable is at most x.
Yes, sir.
So this is defined for every real number for all x belongs to R. Okay, so for all x belongs to R it is defined. So probability of that event for which value of the random variable is at most x. So that means it will be what? We will add all such probability mass function.
Yes, sir.
Summation over y, where y is less than equal to x, correct or not?
Yes.
For different y value, we will take the probability mass function and we will add the things. Up to which we will add whenever y less than equal to x, up to that we will add. That thing is our cumulative distribution function. Okay.
Yes.
Now it will be clear if we do with example. So suppose same example we are taking x equal to number of head tossing a coin 3 times. Tossing a coin thrice. So what are the, already we have calculated that one. What are the x value? X takes value 0, 1, 2, 3. Corresponding probability is 1 by 8, 3 by 8, 3 by 8, 1 by 8. That we know. Now we will calculate cumulative distribution function. What is cumulative distribution function? Fx equal to probability of x less than equal to x, which is nothing but summation py, where y less than equal to x. Up to that we will add. Now arbitrarily I am calculating something. First suppose you are calculating f of 0. What is f of 0? Probability of x less than equal to 0. How many points? Only 0 points. Probability of x equal to 0. So that is nothing but p of 0. That is 1 by 8. F0 is okay. What is f of 1?
Yes, sir.
Probability of x less than equal to 1. How many values are there? 0 and 1. So p0 plus p1. 1 by 8 plus 3 by 8, 4 by 8. What is f of 2? F of 2 I will calculate later. What is f of minus 1? Probability of x less than equal to minus 1. So x less than equal to minus 1. What are the value of x? No value of x. So probability of empty event, it is 0. Is that okay? F of minus 1 0. Hello? F of
Yes,
minus
sir.
1 is 0. What will be f of minus 2?
0.
0. F of
Yes, sir.
minus 0.5?
0.
0. Basically
0.
before left hand point all are 0. Correct or not?
Yes.
Okay. Now suppose we are calculating f of 2. F of 2 will be probability of x less than equal to 2. That means p0, p1 plus p2. So it will be 3 plus 3, 6, 7, 7 by 8.
Yes.
What will be f of 2.5?
0.
Not 0.
7 by 8. 7 by 8.
7 by
7 by
8.
8.
P0, P1, P2, 7 by 8. See, before, then similarly you can calculate f of 3. F of 3 will be x less than equal to 3, so it will be
7 by 8.
no,
1.
P3, 1, P2, P3. You sum it, it will be 1.
Yes, sir.
Remember, left hand point,
Okay, sir.
before left hand point, it is 0. 3 is the right hand point. Right hand point, it will be 1.
Yes, sir.
In fact, right side of that, it will be what? What is f of 4?
1.
1. Probability of x less than equal to 4. Again, same way, P0, P1, that is up to P3, P1, P2, P3, that thing is 1. So, before left hand point 0, right hand point onwards, it is 1. And the
Yes, sir.
middle what are the value? See, if we can
That
draw,
we have calculated.
if we draw a graph, it will be clear. See,
Yes,
suppose
sir.
this is x-axis, this is capital Fx. This example, before 0, it is 0. So, right color is the graph. So, that is up to 0, before 0. So, that's why we are getting open type of things here. Okay. Then at 0, what is the value? I have calculated things here. I am showing you the thing. At 0 value is 1 by 8. So 0, suppose this is the height 1 by 8. Okay. At 2 value is, at 0, at 1 value is
4 by 8.
4 by 8. So suppose that height is this one. Okay, this is suppose in a, I have to take small height, otherwise so suppose this height is 1 by 8, this height is half. So 0, 1, 2, 3. Then 2 it is 7 by 8. 3 it is suppose 1. Okay. So up to before 0 value is 0. After 3, what is the function?
1.
Constant function 1. Now 0 to
Yes,
1.
sir.
What will 0 to 1? What will be the function? See, after 0,
Increasing.
if we take 1.5, not increases. Function increases, but 0 to 1. If we consider
Yes,
this
sir.
interval, 0 to 1, if we take any point, 0 to open 1. So, if you take any point, small px is 0, except 0 and 1. That's why, whatever f0 value, up to 1, I mean before 1 value will be same. Correct or not?
Yes, sir.
So, that's why graph will be this way. This open end here.
Yes, sir.
Then here, up to here, open end. Here, it will start from this point up to this. This point up to this point up to this, then 1. So which type of function? Step function. Step function will be in some interval, it is not a constant function, but interval wise it is a constant. See, this is like step, that's why
Okay, sir.
this is called step function.
Yes, sir.
So capital Fx, increasing or decreasing, what?
Yes, sir.
Increasing. So either increases or constant. Some portion it is constant
Yes,
or
sir.
increases. Okay, so before left endpoint value will be 0, after right endpoint value will be always 1. And in between that, interval wise, it is a constant function. So that is a step function.
Thank you, sir.
Okay, so stop here or continue 2 minutes?
Continue this in the next class. Yes, sir. Next class, sir. Please, sir.
Okay. Okay, anyway, you are giving that time. Okay, thank you so much. So classes
Thank
are
you, sir.
clear?
Sir, attendance.
Actually, attendance, actually 2 days, no class, what?